Okay.
Mhm.
Well, uh, my name is Christian Hyde Andersen. I'm the project manager of the Danish EPS Association. With me today is Martin Henriksen from ICO, and you are also the chair of the Polyurethane Association in Denmark.
Yes.
And we have Franklin Okawa, who is the
Okay.
leading fire safety expert in Europe. He works for the Modern Building Alliance.
Yes.
Here, the PU Association and the EPS Association in Denmark are working together into this plastics pavilion with a theme on modern installation that is lightweight, compatible with fire safe constructions, and climate friendly. So we also wanted to address the issue of fire safety, and we've invited Franklin
Yeah.
to that.
Yeah, we have two different kinds of plastics insulation.
Yes.
We have decided to say that okay, we have the same issues with our components, with our competitors in Denmark. So instead of looking at old-fashioned insulation, we would like people to look at modern insulation.
Yes.
That's why we have created a website, a common website called Moderne Isolering, which leads up to your talk about modern building. Yeah, association.
Yes. Okay. Yeah.
Well, welcome, Franklin. We're all looking forward to hearing what you have to say. And for those of you that want to learn even more on fire safe construction with modern insulation, PU and EPS, you can also join online on LinkedIn or show up here tomorrow at 8 o'clock, where Franklin will continue his extensive talk on why modern insulation is fully compatible with fire safe constructions. Thank you, Franklin.
All right.
Thank
Thank
you.
you, Christian, for the warm welcome. And yeah, we'll get to it. This morning when I was leaving, I almost left my house without my jacket. And I remember somebody told me it rains a lot in Denmark. So I'm lucky I have it, but still, I still feel cold. So sorry if it affects my voice. So I'm here today to give you a presentation on this topic, construction plastics compatibility with fire safety. Like Christian said, my name is Franklin Okwa, and I'm a fire safety engineer. I work with the Modern Building Alliance. So Modern Building Alliance is an European alliance of trade associations and companies representing plastics industry in the construction sector. So we work mainly, or we operate mainly at the EU level, and we are based in Brussels. So fire safety is a key it's a key driver in our product design and manufacturing. That is why, by engaging with policymakers and stakeholders, we are committed in supporting the EU in ensuring safe and sustainable construction and ensuring that EU citizens are safe in their buildings. So this conference has been centered around sustainability. And sustainability, what are the key drivers apart from trying to move away from fossil fuel, the use of fossil fuel, is also the demand for sustainable buildings and energy efficient buildings. And this is evident in the currently passed EPBD, which is the Energy Performance of Building Directive, which passed through the European Parliament. And here there are a lot of targets and demands we need to meet in the coming years. So one of those is that all new buildings should have zero emissions by year 2028. And where possible and economically feasible, should be equipped with solar technology by 2028. So that's very ambitious. Residential buildings have to achieve at least energy performance of class E by 2030 and class D by 2033. So like I said, ambitious, and we are trying to see how much we can go with this. So, and member states are being tasked to ensure that they provide measures for this to be achieved in their renovation plans. So why the need for sustainable building and green energy? So we have issues with climate change, energy crisis, with the war going on in Ukraine, Russia, high cost of energy. So we need to save energy. and we have to make our buildings more sustainable. So what are the implications of this on the built environment? Is that there is going to be more and more innovation, and new products are coming into the market. And now we can see e-bikes, electric cars, charging spots, a lot of it everywhere. And all these are also introducing new risk in the built environment, as well as new technology. And I'll show an example of a new technology is trying to generate electricity using PV systems. And we have basically two types of the PV systems, the building integrated PVs and the building applied. So as the name suggests, the building integrated is well part or integral part of the building construction. So it is the products are well tested and classified according to the CPR, which is the construction product regulation from the EU. And the second is building applied PVs, which more or less are not required to be tested or classified. So what are important with this is that important for the reaction to fire is the front and back sheet of PVs, the embedded material, and the geometry of these systems, because they in one way or the other play a role in how the fire behaves. And then the PVs itself could be source of fire ignition. The connectors could be wrong, cables and the gutters. We have inverters, batteries storing energy. So all these things are all new risks. But then sustainability with plastics, I cannot go too much into this because the whole topics today has been on this. But the point I'll try to make here is that all the ambitious targets that I've stated earlier will not be possible, will be difficult to be achieved if we don't employ the solutions provided by plastics in the construction industry. So here is a very good example, having energy efficient building with plastics insulation. That means we are going to have thin insulation system. And today in Europe, the buildings consume about 40% of energy consumed in Europe. And 70% of that is due to heating. And that you need most efficient solution you can get, which the plastic insulation can offer you. And because they have high performance insulation characteristics and also very thin to qualify to other available products. And I think it jumped. So other properties for plastics in construction. I cannot over say this because that's what we've been going through the whole day. Durability, weather resistance, energy efficiency, cost effectiveness. You have low maintenance, and the materials are usually lightweight, so they are very easy to install and to move about and even renovate. And one good quality to this is that these products are recycled, and recycling them. Okay, I think I jumped this. So this is more or less how much plastics that are produced in Europe, and about 21% of them goes into building and construction. So the first major use or the first market for plastics will be packaging, and then you have the building and construction. So we have a lot of solutions provided by plastic materials. And this as well could be recycled and also go back into the building and construction. So you can have roofing systems, floor pipes, a lot of window frames you can make out of recycled materials. But what is the challenge is that plastics are combustible. And so, like other organic products like wood and wool, but they can be safely used in their intended building applications when installed correctly, and this has been proven through performance-based testing. So, and the picture I put here, you have typical fire. You must have these three elements present. You must have heat, you must have the oxygen in the environment, and you must have the fuel, which any solid combustible provides. So this is very important in the follow-up slides. So every solid that is combustible, both including plastics, wood, they all pass through these four steps of they pass through these four processes. First is the heating part. So when there should be heating enough to paralyze or thermal decompose the material, and which now have to give up a flammable mixture that will be ignited. And the fourth process will be trying to repeat this process again, because without enough heat, you cannot sustain this combustion. And fire combustion is usually controlled for burning solids by the physical state, distribution of the fuel, and the environment. So for environment, this determines whether the fire is under ventilated or ventilated fire.
What is fire ventilated and fire under?
For example, I give you a typical example. Inside the room, there's fire in the room. You close all the doors, and the fire consumes the present oxygen, and it goes off. But then, if you suddenly opens the door, you supply more oxygen. So that's why I said this graph is very important. So that means when you are inside the room, you provide the heat, which is the fire itself, and the oxygen. If the fire consumes all the oxygen in the room, it goes off. And if you open the window or open the door, it introduces new oxygen into the environment and it goes on burning. So that's why it's very important to have a very good understanding of how things are burning rather than what is really burning. So how do we deal with this in the industry? Is first, like you mentioned before, the use of retardants. You can add flame retardants to the products to improve their reaction to fire. And also, there is the construction product regulation used in EU, and this is a way to harmonize how construction products are distributed around Europe, and they provide more clarity on how you can trace these materials. So what is important here is that construction products are classified according to their reaction to fire. So you have different classes. For example, concrete will be A1, and you have other products coming up, depending on how they contribute to the fire. Where class F means probably there is no classification for such material. And there are other additional classifications, the smoke droplets, the smoke production, and also flame droplets. So, but what is important is that for assessing contribution of any product, be it plastic, be as far as it's a combustible product, is first of all to know the reaction to fire, how this material reacts if there is fire. And again, how does it perform when it's in a product, and when it is assembled with other products, how does it perform? And again, how and where does this product or how and where are they installed? Because when you have a very bad example, when you have a product that's meant for the roof and you put it somewhere else, it has different behavior, which is different from what it was produced for. So if it's meant for the roof, it should be on the roof. So here I try to add some statistics about how we have grown with fire. So the most important thing here to note is that the major causes of fire are the misuse of equipment and 40 appliances. All this leads to electrical safety, which is very crucial. And this is one of the points our organization is trying to push, that we have more electrical safe, the electrical installations, to make them more safe. And the more safe they are, the less the fire we have. Because if you don't have fire, nothing else will burn. So this also leads to prevention, but we'll come to that later. And then trying to look at statistics coming from the UK. So we see over the decades, the number of fires we have are all going down. If you check from what we have since 1999 till now, the graph is going down, and it is the same for this is from Spain. So you can see the same trend, but it's difficult to use these statistics to compare to other states or other countries, because the way statistics is being collected in Spain is different from what is done in Denmark, and different from what is done in the UK. So it will be different to compare the statistics. So, but currently the European Commission is working towards harmonizing this to make it that what we collect in Belgium will be the same information collected in Germany, will be the same information collected in Spain. So this way, the fire statistics will be easily comparable, and this way the authorities can make more informed decisions. Because, for example, how the buildings are classified in Spain, say what is high-rise building, it could be 7-story in another country, and another country could be 3 stories. So fire statistics coming from Belgium say 3 stories is already high. For example, just giving an example. So now we try to harmonize this to make sure that what is referred as high-rise building in Belgium is the same to what is high-rise building in Spain, and the same what is high-rise building in Denmark. So that way, when we collect data about fires in high-rise buildings in Europe, we can easily say, oh, it's going up in Belgium, it's coming down in Denmark. Then we want to know what is happening in Denmark that is coming down, so that we can apply them in Belgium, we can apply them in Spain. So more or less, this is it. So what is the plastics industry doing to improve this and to improve fire safety in their products? Is we created this fine framework, which we call the holistic framework to ensuring fire safe in buildings. So this framework is to provide solutions for the member states that they can apply in their regulations and the national building codes to help solve fire safety related issues. So we call it the BIO framework, and more or less the topic for tomorrow is all based on this. And I will try to go one by one, step by step, to explain what we have there. But the most important thing for us to take away from today is that fire safety engineering is very important in solving the current fire safety challenges we are having these days, because the level of innovations, new materials coming into the market, they are way going faster than the regulations can catch up. And we can only use fire safety engineering and the science behind it to have more better understanding of these materials, and also the results from performance-based testing. We can already use them to create more solutions. The summary of this is what we call the 7 layers in fire safety in buildings. So these 7 layers says that before you can start thinking about fire safety, it's best for you to have a holistic view of the whole risk in the building. So you first have to think about how first can I even start preventing fire from occurring? So what do I need to do to prevent fire? So if you have exhausted all the things you need to do to prevent fire, and then next thing will be, if the fire happens and I could not prevent it, what do I do? You need to detect it. If you detect the fire on time, you can attack the fire on time, you can put it out on time. If you cannot, if you detect it, then early suppression is very important, and then you can have more time to escape. And if that is not working, we need to create best and possible evacuation way to evacuate the people from the rooms. And we also need to think about creating compartments in the building. So this way we can isolate the fire room origin and then not let smoke to move from the area where the fire started and move in another place. And if the fire is so much, we need to ensure that the structural integrity of the building is intact, that the building does not collapse. For example, if the firefighters have to come in to fight the fire, so we have to ensure. So this is all the things in fire safety engineering that you have to first have at the back of your mind before you make any design of a building. So you have a building, you calculate all the possible risk in that house, and then you can start going from one stage to the other to make sure that all these layers are covered. So this probably will bring me to the conclusion, which says we know that there is increased need in energy efficient and sustainable buildings. And meeting these needs and targets will be difficult, if not impossible, without the solutions plastics provide. And we can as well use plastic safely in building when you apply them correctly. So when a product is classified to be used as facade or used on the roof, it should be used on the roof than used elsewhere. And what is more important in this is developing the fire safety knowledge and competencies is very important to accompany the renovation with. So, and finally, it's also very good to have a complete risk assessment of the whole building to really understand what the risks are. So, for example, okay, you make the whole house of concrete and you have 200 people in the building and you put one exit door. If you have the slightest fire, or even when there is panic, one door is not enough to evacuate everybody. So these are all the things we have to think. See the building as a system. The number of doors you have determines the number of people that can escape. And what you put on the roof determines how much wind can be in the house or what can go in there. So everything plays a role. Nothing is different from the other. Everything is a whole system. So you see the building as a whole system. The size of staircase you have determines how fast they can descend or go up in the staircase. So yeah, this will bring me to the end of my talk today, and thank you for listening. So I will take questions now, and if you have questions. So also, if you have time tomorrow, more will be coming to have more detailed explanation on the 7 layers, the BIO framework, and how you can holistically tackle fire safety in the buildings. So thank you very much. Yeah, please have questions.
Perhaps tomorrow.
I thought that they were keeping the questions for me.
Thank you very much for coming, Franklin,
Yeah,
and thank you all for attending. And looking forward to seeing many of you tomorrow for part 2 of this.
Yes.
Thank you.
Yes. Thank you very much.